Welcome to this University of Idaho Extension video on dairy manure application using a drag hose and subsurface injection system. Subsurface injection of liquid and slurried manures has been used for many years in Europe and in eastern and midwestern states in the U.S. This video shows the basics of the injection system using a drag hose as the manure transport system. The video also shows results from research conducted by the University of Idaho as we demonstrated the applicability of the system to the semi-arid western United States climate and farming environment.
The drag hose and subsurface injection system components are a manure storage lagoon or tank common to most confined animal operations manure management systems. Proper to the drag hose system we have mixing pumps and impellers, which might include floating pumps and shore-based devices, a sludge and lagoon wastewater pump, a drag hose, and an injection system. Let's see how these components operate and what function they have in the system.
Manure management systems include a facility for storing liquid manure until it can be land applied. Typical structures include liquid storage ponds, lagoons, or tanks. In the western U.S., storage lagoons are commonly used. The first component we will discuss is the floating mixing pump. There are several models of floating mixing pumps. Today, it is common for the pumps to be fitted with a remote control so the system can be operated from the shore. In this case, the producer is using a single pump and engine system. This arrangement allows him to alternate functions between mixing the lagoon and pumping the mixed liquid through the drag hose system for injection. The floating pump has an engine and a chopping pump that can chop and pump debris like straw, small wood pieces, and other objects that may be present when mixing a dairy wastewater lagoon. The system has a series of nozzles that can be redirected in several directions, using either the remote control or controls on board the float. These multi-directional nozzles allow the floating pump to travel through the lagoon, be positioned wherever the producer wants it, and mix the lagoon sludge and water previous to injection. In general, after mixing, this producer returns the float to shore for easy access during pumping operations. Systems with one pump and engine need to stop mixing while pumping. Floats can be fitted with a set of two engines and pumps, allowing mixing and pumping at the same time. However, this configuration considerably increases the cost of the equipment. Onshore mixing devices include the impeller, pump, and cannon systems propelled by a tractor's PTO, as shown in this image. These systems help increase the mixing area of the floating pump and to keep solids suspended during pumping operations. However, using just the impeller to mix the manure without using the cannon does reduce odor and other emissions considerably. As we mentioned, pumping can be achieved either by using the mixing pump or by having a second pump dedicated to pumping to the fields. To extend hose life, care should be taken when laying out the drag hose so kinks, sharp turns, and objects are avoided. Do not stand close to the hose when it is pressurized to avoid potential injury due to hose rupture or repositioning during pressurization. Drag hoses can be laid out for several miles, but a booster pump is needed about every 2.5 to 3 miles. Two-way radio communication equipment is recommended so the pump operator can communicate on a real-time basis with the injector operator. This assures a smooth and precise operation. In this way, incidents like spills can be avoided and the operative adjustments can be made promptly.
We asked the dairy producer and his farmer contractor to explain what they do when operating with low temperatures and when night freezing is a problem, as well as how they manage the drag hose on the field and how they change field sections.
Yeah. At night, when the weather is cold, what we do is we take an air compressor, like you'd run a jackhammer with, and you take a foam ball and you put a cap on the end of that hose there, and it'll send that ball through this hose and just clear it all out. It'll come out the end about 150 miles an hour. And you can, shut down for the night and start again in the morning. No big deal.
Then to move from field to field, you roll the hose.
Yeah, we gotta blow it first,
Blow it.
and then we got a hose cart that's up in the yard, and it just wraps it up. We can probably pull in at least 3 joints, 600-foot joints. Just pull them.
Uh-huh. Oh, pull it with the tractor.
Just
through
with the cart.
field.
The cart has hydraulic drive,
Uh-huh.
and it just wraps across it.
Okay.
And then we just take and go. Mainly, if we'll move like this, we'll move down, and then we will start. We'll have a point, and then from that point, we'll go several ways. Because you only can do 40 acres at a time. The way math works, you lay this hose from kitty corner to kitty corner, and then you start pulling it back and forth and working out to a point. Then if you go clear across and then come back and then pull it back straight, and then you can kind of pull it all back straight again, and then you can start doing this half. But you got to work always in angles. Yeah, so you don't get tangled up. And so we run out of traction more than power, pulling the hose. But you'll run to finally just spin out. But we can do a 40 at a time. And so now we're working on a full pivot, and we'll do it in 4 pieces. But that's about all you can do. The guy that sold us this, he runs bigger hose, bigger pumps, bigger tractors. He can pull farther, but he spent a lot more money. But he will take and put another jump pump down, halfway down, and boost his pressure, and he'll run 8-inch hose clear out there where he's pumping 2,000 gallons a minute. He said he's pumped up to 4 miles away.
After learning how to extend and move the hose between different sections of the field, the operation is relatively fast and easy to perform with trained operators. Care must be taken to avoid entanglements and running over sharp objects during both the extension and movement of the empty drag hose and during manure application operations.
Tractor speed and gallons per minute pumped will determine the injection rate. Here you can see the difference between injection with the shank down and application with the shank up. We use this as a demonstration for comparison between the injection system and the broadcast system. During normal operations, the shank is lifted only during turns to reverse course. The drag hose and injection system are coupled with GPS, flow meter, and tractor autopilot, allowing for precise application. The operator is aware at any time of the rate of liquid application and how precise the application is to avoid gaps or double application at each pass. The GPS autopilot combination reduces the driver's workload and increases precision and control of the entire operation. The system can include an interface to map the rates of manure application on each field for nutrient management and record purposes.
Through a conservation innovation grant from the NRCS, a team from the University of Idaho Extension collected on-farm data to demonstrate the effectiveness of the drag hose and injection system compared to a broadcast system. Ammonia emissions were assessed using passive ammonia samplers. Odor emissions were assessed by taking samples and analyzing them via olfactometry. An economic analysis was done based on bibliography and local operations costs.
In this graph, we can see the difference in ammonia emissions during the first 2 days after manure application using the drag hose and injection system compared to the broadcast system and to background levels. Readings from our 2 test sites were consistent and were consistent with other studies. Odor reductions were observed when comparing the drag hose and injection system with the broadcast system. These reductions were consistent with the observed ammonia reductions and with the results of other studies.
When compared to other liquid manure application systems, the drag hose and injection system is very competitive. An initial investment cost is expected, but the drag hose system can have a return on investment that is quicker than other application systems. This analysis does not include the additional benefits that drag hose and injection systems have, like lower nitrogen losses, keeping the nitrogen in the soil, odor and runoff reduction, and other benefits such as better neighbors and community relationship, and reduced risks of fines due to complaints or runoff events.
The drag hose and injection system is one of the most competitive, cost-effective, and environmentally safe options available today. This system is an excellent alternative for achieving precision manure application and nutrient management goals, thus increasing nutrient retention and reducing environmental impacts and risks. Increased use of this technology by farmers and livestock operators should further reduce its costs. Drag hose and injection systems are without a doubt a very welcomed advance in agricultural waste and nutrient management.